Okay, let's get started. This is one of the questions from 3.3 that was assigned. I promised I would work one of those. And so I have chosen number 83. I copied the problem down, and I want to go through with you how I worked this on my own. The first thing I noticed is that there was a common x. So I factored the common x out of this function, and that left this function to be looking at. So the next step was to take the coefficients of this and try to figure out some of the zeros. I could use my calculator when I get it down to x to the third or x to the second power, but I can't use my calculator when it's to the fourth degree to solve it, okay? Plus, it's good to know how to solve it anyway. Since these are all positive signs, remember that Descartes' rule of signs said that if they're all the same and there are no sign changes, then we have no positive zeros, okay? So we're looking for negative zeros for this particular polynomial. If we can put in a minus x into this, and it will change this term and this term, so the sign will change 1, 2, 3, 4 times. So we either have 4, 2, or 0. No, we have 1, 4, 2, or 0 negative zeros. Is it 2 or 0 or 4, 2, 0, Buzz? 4 sign changes. 4, 2, or 0. That's what I thought. Okay. So we know that this answers the real zeros, not the complex, but the real zeros will all be negative for this particular polynomial. Okay. So I said, in order to make this work out with synthetic division, I'm going to have, since the number goes up and then it comes down and then it goes back up, the direction changes here in the coefficient. I know that somewhere I need a negative, so I started guessing negative zeros. And to make my guesses, I used the old P over Q to come up with all the possible solutions. Now let me find that page for you. Oh dear, dear, dear. Well, I can't find it, so we'll just go ahead and look. I started using small numbers since these 36 is sort of large, but I started using -1 and -3 and so forth as I tested my values, okay? That was my system for doing it. There's no magic way. So I first took the coefficients, and that was a 2, 11, 16, 15, 36, and I used that for synthetic division. I chose to try -1. I know the solutions are negative, the real solutions, because of all these signs being positive. So I went ahead and did synthetic division, and as you can see, my remainder was not going to be 0. So I said that is not a solution. -1 is not a solution. Remember that you can pause this if you need to copy something down or look at it. Then I tried -2. I thought I'm just going to be systematic about this. I'll try -2 next. I have a feeling it's a small number because these numbers are not that huge. So I tried -2 in my synthetic division. I could see I would get a -22, and whatever it is, I have a remainder. So this one I also concluded -2 is not a 0 of this particular function that we're working with. So I said, let's try -3 now. Okay, and I'm just doing a guessing game systematically, and I may have to guess all the way up to 18, right? -18. That would not be fun, but divisors with my P over Q. So I tried -3, and yay, I have a remainder of 0. I didn't write it down, but as you can see, I do have a remainder of 0. So I say -3 is one of the zeros of this function. So at this point, we go back up here, and the question asks us to find all the zeros. First of all, we pulled out an x, so x equals 0 is a 0, so we have one 0 at 0. And we now know we have another -0 at -3. Okay, so I'm just going to come back to this page as I list and find all the other zeros. Now we've broken it down to these coefficients. We had an x to the fourth, right? And we divided an x out of it right here, which brings this down to an x to the third, 5x to the second, 1x, and 12. This is the polynomial that we're left with, the function. And so I grabbed my calculator and I did polysolver on this. And when I did, I came up with the first solution. Okay, I went into the third degree equation. You can see the first solution was -3, and the next solution was ugly, right? All right, let's look over. I don't know. It's not good. It's an irrational number. I can tell that that decimal just keeps going and going with no pattern, irrational. And the third solution, same thing. So I'm not going to worry about that now. I'm just going to notice that -3 is a solution again. So this is one of those that occurs twice, right? So if we were writing the factors, there would be an x, and there would be an x minus a -3, x plus 3, to the second degree at this point. Okay, so if we're factoring it, this is what we have so far, but they're asking us for the zero, so I'm just kind of getting carried away there. Now this this being a zero, I can divide it again with synthetic division, so that's what I'm going to do. Take the polynomial that we had here, 2, 5, 1, 12, 2, 5, 1, 12, and take the -3 out of it, and that brings us to a second degree equation. We have a 2x squared minus 1x plus 4. Very well. This being a second degree equation, I can either factor it, but looking at this poly solver a minute ago, I can tell it's not going to factor. So I'm going straight to the quadratic formula. Okay, and here's what I got. -1 plus and minus the square root of -1 squared minus 4 times 2 times 4 all over 2 times 2, right? Because A was 2, B was -1, and C was 4. And I plug that into the quadratic formula. And then I reduce that, and I get -1 plus and minus the square root of -31 over 4. But the square root of a negative is like an I, so it's really, this is what we want right here. 1 plus and minus the square root of 31 I over 4. And so I can go back to my solution set, or put it on the first page there. The next solution is 1 plus the square root of 31i all over 4. And we could do plus or minus, or I write it again, 1 minus the square root of 31i over 4. Okay, those are the zeros. Okay, and then to do this factor, it would be sort of ugly, and I'm going to just leave it at that. Okay, the main point of this was I wanted to show you if it occurs twice in the factored form, it has to have degree 2. Okay, they ask us for the zeros, and that's how we go about it. Look back at the rule, Descartes' rule of signs, in terms of helping you guess the zeros, whether you're guessing positive or negative numbers. And then you just have to do a lot to practice to kind of get a hunch for it. Again, my observation here that I needed some negatives was helpful. Plus, we knew that from the rule of signs. Okay. I'm going to stop this and put the other part in a different video. So I'll come back and complete lecture 13.4 in a second.